Good afternoon and welcome. My name is Jennifer Taylor and I'm the President and CEO of NVTC. I am delighted that all of you have joined us for the first day of NVTC's Impact AI Summit. NVTC is the trade association representing the Capital Region's tech community. We connect, educate, and accelerate innovation for our members to advance a thriving tech ecosystem where we all live and work. This region offers a unique set of artificial intelligence assets that no other region in the world can match. Fortune 1000 companies, entrepreneurs and investors, proximity to and expertise in serving the federal government customer, a highly educated workforce, an unparalleled research infrastructure, and top academic partners. This ecosystem is dedicated to developing innovative AI solutions for both commercial and public sector customers. And that's why we're here today, to explore and highlight these solutions. We have a very exciting program for you today. Before we invite our first speaker to the screen, I want to thank the companies and individuals who have made today's summit possible through their financial sponsorship and also their guidance and expertise as members of our event steering committee. Our platinum sponsor, Accenture. Our gold sponsor, Ericsson Immigration Group. Keynote and panel sponsors, Digital Realty, Devel Technologies, and SAIC. Silver sponsor, the Fairfax County Economic Development Authority. Our program sponsor, George Mason University. Our PR and marketing advisor, the Merritt Group. Public policy advisor, Hunton Andrews Kurth. Our marketing agency advisor, O2KL. Our media partners, iHeartMedia, Scoop News, and Washington Technology. All of these sponsors have made the content today possible with their generous support and guidance. I would also like to thank NVTC's business partners and academic partners for their year-long support of NVTC. They are Booz Allen Hamilton, Center for Innovative Technology, Consumer Technology Association, Deltec, Dominion Energy, George Mason University, Innova, KPMG, Maximus, Microsoft, Noblesse, Northrop Grumman, PenFed, Pillsbury, PNC Bank, SAIC, Venable, Verizon, and Virginia Tech. A quick reminder for anyone who wants to tweet from today's event, we'll be using the hashtag ImpactAI. Now please help me thank Brad Antle, one of the chairs of today's event, who will serve as your MC today. Brad, your leadership has been absolutely critical to pulling this event together. Thank you for all you have done to make this summit a success.
Thank you, Jennifer, and we appreciate your leadership at NVTC. On behalf of my co-chairs, Charles Onstott III from SAIC and Tom Oteki from Virginia Tech, I'm excited to be here. We have a content-rich program today filled with top AI leaders and companies. At the conclusion of today's presentation, we will have a period of time for Q&A with our speakers that will be open to any of the subjects that were presented here today, and we'll try our best to get through as many questions as we can in the time available. Please use the question button at the right side of your screen to post your questions throughout the presentations. Please identify the speaker your question is for, and please don't wait until the end. Now let's get things started. To kick off our program, I'm delighted to introduce today's first keynote speaker, the Honorable Katrina Mcfarland. She's a commissioner on the National Security Commission on AI, or NSC-AI, and the chair of the National Academies of Science Board for Army Research and Development. The NSC-AI is an independent federal commission created by Congress in the 2019 National Defense Authorization Act to, quote, consider the methods and means necessary to advance the development of artificial intelligence, machine learning, and associated technologies to comprehensively address U.S. national security and defense needs, end quote. Katrina joined the SAIC board in 2019. Prior to her onboarding, Ms. Mcfarland was the director for Agility Holdings, Inc., from 2017 to 2019. In 2017, she retired from the civil service as the Assistant Secretary of Defense for Acquisition. She was appointed to this position in 2012 by then President Barack Obama and confirmed by the U.S. Senate. Katrina is going to tell us about the National Security Commission on Artificial Intelligence's final report, which was submitted to Congress and the President in March of 2021. It presents an integrated national security strategy to reorganize the government, reorient the nation, and rally our closest allies and partners to defend and compete in the coming era of AI accelerated competition and conflict. With that, please welcome Katrina Mcfarland.
So thank you so much for the opportunity to speak about the National Security Council's on Artificial Intelligence report. For those of you that aren't aware, back in 2019, the National Defense Authorization Act requested that the government take a look at and assess the global position of the nation with respect to artificial intelligence and where it is regarding our national security posture. There were about 15 commissioners assigned to this from various elements of Congress and the Department of Defense and several other cabinets. And for the most part, they were very senior technical people in industry. And then there were a few folks that had worked in the government, such as myself and Bob Work. So we had people like Google, Amazon, et cetera, come and I learned a lot from these individuals, and they learned a lot about where we were postured. The Commission's first report, which was in November of 2019, was a report that assessed that position, and then in concert with the NDAA, the following year was focused on recommendations. And what we discovered was our armed forces and the nation's competitive military technical advantage and economic advantages can be lost within the next decade if we don't accelerate the adoption and creation of AI across the nation. And what we had for an effort that took a year really was transformational. We did it at all levels of classification. And just to give you an indice of how important that baselining and assessment was, one of our corporate partners, commission seniors, took all of their assets out of China within 2 weeks. So if I were to do what I think was justice to this report, because it's 743 pages long that we just released as a final report back in March, I would have to take far too much time. So what I'm going to do today is I'm going to provide a teaser for each of you to go to the National Security Council's Commission website, which is NSCAI. Just Google that and you will get access to the website. And there is an interactive play that you can do. You can get and download the final report. You can focus in on chapters. There are 16 chapters. And you can actually read the executive summary, which I recommend most for folks that are challenged for time and access. And take a look at what it says. And like I said, the first part indicated to us that we are in, as a nation, a competitive war that is about the future. Just to give you some sense of that, China about 5 years ago put billions into investing into artificial intelligence and all of the aspects of its capabilities. And we believe that if we don't take a look at what we need to do right now, because our assessment included, as I said, that we weren't competitively positioned, we don't have a strategy at the national level, and we haven't put the adequate resources in place, that we would be behind in AI by about 2025. And so with that in mind, the report was written in 2 sections. The first section is, I call it getting AI ready, and that's setting up our country to be prepared and able to adapt and utilize AI. And then the second part was getting AI enabled, which is taking AI to the next level. The important part of this is to understand that we have a lot to do as a nation. I'm going to read to you the 5 major threats that we saw that AI has undermined in our country, and then give you solace that we have adequate tools and the ability to overcome them, but we need to focus on them right now. And you've all heard about the information operations that has been utilized against this nation. It's involved in voting, it's involved in finance, it's involved in the press, it's everywhere. And it has been used artfully over the last couple decades to essentially undermine our nation's stability. And that's also things such as, how do we look at data? Data harvesting has been done on this nation for quite some time, and our people aren't aware of that. Accelerated cyber attacks like SolarWinds have occurred. We see the adversarial use of AI in certain pockets, like we saw with Russia's use in the Ukraine. And we see biotechnologies in a space where we believe the lack of policy and structure for the democratization, pardon me, it's a word my tongue couldn't get around this morning, has impacted our futures. And so the important part to recognize about AI, just to give everybody a sense of our view of AI, is that artificial intelligence is essentially us as people wanting to have a task or an effort performed in a different medium. Most of us think of computers, but it can be done in other things. Essentially, when you want something done and you change nature or a medium to do it for you, you've created artificial intelligence. So if you think of it in that light, naturally, the person who either writes the code or creates the chemical reaction or et cetera has biases. And the good thing about that is our nation's biases protect and are driven by principles and biases that our freedoms are based on. So as a people, you'll see in our report a section on the ensuring the protection of our nation's freedoms and our ethics and principles and biases, of which we are apt to do. However, you have to think about that being done through a nation state or a government that doesn't share those, such as China, which, as we know, is a surveillance state. So if we think about where we need to be postured in the future, we need to take a lead in the application science of artificial intelligence and working with like-minded nations to build this format and infrastructure to be sure that we are doing what we feel is the way we want artificial intelligence for our people to be built. And we can. This isn't as scary as it's been made. We just need to write the code. We need to build the infrastructure. We need to set the policies and the standards and do the testing and ensure the safety. And we need to do it publicly, and we need to do it with, like I say, like-minded nations. And that's done and stated throughout the report is we as a nation can do this. We just need to apply resources and focus down on it. One of the things that we saw over the last 2 years with a lot of companies, such as the ones you all see here, is that they have written policies, ethical principles that they will share with everyone, including their own workforce, on how they will design and build. Those things are very, very important. And so let me go back to the structure of the report. Like I said, the first section is AI enabled. And to be AI ready, you need a framework to ensure everybody is marching to the same beat, because of course we're going to have limited resources to do that. So we have top-down leadership and bottoms-up strategy. And first and foremost, inside, I'm going to focus now on the national defense element, but I'll get you back up to the federal level in a second. Inside of the federal space, inside of Department of Defense, we asked for a top-down leadership that included a steering committee on emerging technologies and included the Joint Artificial Intelligence Center's reporting structure, also known as the JAIC, to be to the Deputy Secretary, so that there is the right amount of oversight and insight into artificial intelligence. And we also requested they put AI readiness performance goals in place and put a classified annex on the National Defense Strategy to provide the framework for the goal of how and where the department wants to head. A lot more than that, including how do you write requirements? You want to have educated military and civilians, and you want to have them engage in the use during any wargaming of AI, et cetera. To take it back up to the federal level, however, we also talked about a technology council, technology competitiveness council that would be chaired by the vice president and filled by members of the cabinets who are required to put together a national strategy that obviously would flow down to each of the cabinets and have also metrics and goals to provide the nation a strategy to build in too, which is of course the whole government approach that we've used in the past for things like nuclear or energy. So this is not uncommon, it's just necessary for us as a nation to build towards. We need to, of course, like I mentioned, put resources in place. China has put in an inordinate amount of resources, and they aren't just monetary resources. And recall, their buying power is greater than our own per a spend. We're talking people and organizations. We want a digital ecosystem that's allowing ubiquitous AI development, because we know the future. This is, a century ago, electricity became ubiquitous. Everywhere you turn, you see it. AI is going to be like that. And so we need to make sure that we have access for all to AI software, trained models, data, and development environments that allow people to come in for the Defense Department with appropriate access to clearances to be able to come in and work and help and perform better. And so we see a spend that we're asking for example, for S&T to be equal to about 3.4% of the total budget and about $8 billion on AI and AI R&D nationally. So we have already worked from essentially November of 2019 through this past March on providing accelerated inputs to Congress for them to put into the National Defense Authorization Act and the appropriations. And as you probably are aware, we've been very successful because we worked together very collegiately. They were incredibly supportive, and about already 75% of the recommendations have been put into legislation or appropriations, and the last final 25% are being deliberated right now. So I mentioned leadership, and secondly, resources and organization. And then the third is adoption. And I sort of alluded to that. And that is, for the Defense Department, we need to have people with the appropriate skill inside of the system that develops requirements. So the combatant commanders and the services, and in wargaming, there needs to be the appropriate people with the skills to help prioritize and demonstrate and offer ways of the technology to the warfighters for them to work with, learn from, and help prepare themselves. And the last thing is, to get to the ability for the procurement system to work, they need to be able to validate, test, and ensure that they are safe. And I already mentioned that we already, as a principled nation, do things very detailed and rigorously and built in with safety precautions. And this obviously could slow us down if we don't adapt it to how the digital era works, and to use the tools that provide us that confidence that are of this century and of this decade. And so we recommend investment into test, evaluation, validation, and verification tools in the education and essentially access for this. So that's essentially getting us ready. And so the second piece is enabling us. And in enabling us, we really have to take the sense of, where do we go from here? We need to think about how to invest in areas, and you'll find at the end of the report, the last chapters talk about things like quantum computing, bringing microelectronics back on shore and jumping a generation in the design of microelectronics so that we can have already in place assets and tools that will inform and be built in the nation's view of protected and privacy and freedom, so that we have an infrastructure ready and able for us to continue the design. And so we believe that this second section, or the second part of the report, is singularly focused on how do you get to the next level of AI. And just to give you some teasers, because I think the first part is most important to focus on to be ready, but when we think about our second piece, which is how do we get into enabling us in the future to be the economic lead and to provide for the infrastructure that we as a nation want to operate in, we talk about a strategy for competition and cooperation, and that works with internationals. And how do you bring the talent competition to our shores? We're concerned about the erosion not only of our intellect and our ability to perform and train and educate and use. We're wanting to retain, and we want to be able to ensure we protect. So there's another thing about accelerating AI innovation by bringing aboard and bringing talent in, but also allowing for that talent to stay, to with appropriate clearances and appropriate vetting, to bring people in and provide them opportunities to stay in the nation, to build upon that history of this country, to take from every area of the world. You know, you're hungry, you're poor, but boy, if you can bring something to this nation that'll help us, we want you, especially if you agree in our freedoms and principles. And so the international situation, how do you protect your intellectual property? How do you create a favorable international technology order? How do we bring in the associated technologies like quantum, like biotechnical research? All of that is in the second section, and we attribute resource issues and how to bring the money to the table for us as soon as possible. And so I'm going to wrap up there. I know you guys are doing a great deal of work in this area. The commission does take questions. We'll be closing up the shop probably this fall, but there's a lot of folks that are coming from the staff and the actual commissioners themselves that'll be working inside the environment that this is going to be continued with, and we're here to help. And thank you to you all for the work that you're doing. It's very important.
Thank you, Katrina. That was absolutely fascinating. Now I would like to welcome our panel on AI in the Department of Defense. First, our panelist, Dr. Arlene Espinal, is the President of Analytics, Automation, and Artificial Intelligence in the Innovation and Capabilities Office at Mantech. She is a leader in global strategy, big data analytics, and next-generation information technologies that drive digital business transformation. Dr. Cheryl Howard is a principal data scientist in IBM's Cloud and Cognitive Software Expert Labs delivery team. She works directly with clients to architect, build, and deploy machine learning solutions to solve challenging business problems across a broad range of commercial and government applications. Ian Mccullough is the Managing Director and Chief Data Scientist for Accenture Federal Services. His current work focuses on the application of artificial intelligence to improve democracy and government services. And our moderator is Michael Scruggs. Michael is the Senior Vice President over Artificial Intelligence within the Strategy, Growth, and Innovation Group. He is responsible for incubating and leading SAIC's horizontal AI business, comprising solutions related to predictive analytics, machine learning, robotic process automation, and an intelligent edge. He also oversees SAIC's strategic partnerships, training, and certifications, and solutions related to AI. Michael, with that, over to you.
Thank you, Brad. So good morning. My name is Michael Scruggs, and I'm the Senior Vice President of Artificial Intelligence at SAIC in Washington, D.C. And I am really honored and thrilled to be here today to moderate this discussion on the use of data science and AI within the Department of Defense. So before we go into the discussion, just a few thoughts. So we know that there can be many challenges to achieving positive results using data science and AI in our pursuit of solving important business problems. And recently I read some of General Groen's comments as he cites on the state of AI and data science in the DoD, and he cites some common problems and challenges that they're facing in DoD with regards to AI. First, he cites it despite having pockets of success throughout the DoD, and there are pockets of success. But there is a need to build a comprehensive plan for wholesale transformation in order to really leverage AI across the enterprise. And I really agree with this because it's so important to begin with the end in mind. And if you don't, it's going to be tough to achieve meaningful outcomes with data science and AI. Second, we see challenges in transitioning from analytical AI or analysis to operational AI. And Lieutenant General Groen cites that wholesale modernization of infrastructure that allows any sensor to inform any decision maker or any sensor to inform any system as paramount to success. And I think that this is another critical point because the value of the output of AI is only as impactful as the speed and ease with which it's consumed at the point of impact, like by a warfighter or a device that's out at the edge, for example. And then finally, he cites that data is also at the root of AI and analytics, but the volume, velocity, and veracity of data can make it really challenging to harness the value in the data for use in advanced analytics applications. He states, I think quite broadly that DoD can't do it alone, and I think this is a really important point and one of the reasons why we're here. He says that industry involvement is going to be critical to the success of their mission. So I'm really excited about being here today to talk through some of these issues and hear some of our experts comment on ideas and secrets to success, and to engage in the conversation to talk about these important issues. So with that, why don't we get started with the Q&A? So I'd like to start with you, Ian. Let's talk about the differences between descriptive analytics and model-based analytics, and when one is useful and when it's more useful to transition to another. Can you comment on that?
Yes, I think that there is a critical issue with the Department of Defense's application of artificial intelligence, where we have this idea that it's a problem of sensors, it's a problem of data, and we neglect the most important part, which is the models that you were describing. Let me use COVID as an example. If we were looking to say how many people have COVID in the US, right? What are we really asking for? The real question is, what's the risk of transmission? What's the risk of impact on federal workers or soldiers or Department of Defense equities? So if we're looking at the number of people that have reported a case of COVID, half the people we know are asymptomatic and don't even know they're sick. And of the people that are sick, not all of them go to seek medical treatment or even get counted. So the data is simply not there. And it's not even a point of how do we do the data integration? How do we handle the volume of data? How do we address that there's over 3,000 different county public health offices, all with different infrastructure and data systems and all that stuff? Once you get the data engineering correct, right, which I think America did a pretty good job with, it's still inherently flawed. Now, we can take what we clinically know about the disease, we can impose that on a mathematical model, we can recognize the inadequacy of counting symptomatic patients, and we can look at a more reliable data point like death rates, and we can then infer what the true case count is, which allows us to get more accurate models, or more accurate insights. In our work on this, it's within 2% margin of error when you actually look at random samples in Florida, New York, or Texas. And now you can use that more accurate model to infer insights to make decisions that are going to be more important. So, the short of it is we have to get beyond just simply getting our arms around the data, putting it in a consistent platform and counting it. We need to understand how do we model it to drive insights with effective mathematical models.
So I'd like to ask a related question of Cheryl. Cheryl, if we go from the descriptive part of analytics and we fast forward through the continuum to full-blown AI, there are a lot of concerns about explainability and trustworthiness and transparency. Can you comment on the general topic of what does trust mean when it comes to AI?
Right. Well, there's really a number of components to trust, and talking about this with some of my colleagues earlier today, you can't have a single trust metric. There's many components to it. There is the accuracy of the models, so the model performance. There's the quality of the data, as yourself and Ian alluded to. There is bias and fairness, so things like disparate impact on specific demographic groups. And then there's explainability, which is sometimes a concern. Can we explain to a layperson what this model is actually doing? Do we need to, and in how much detail do we need to do that? So all of those are facets of trust in AI. If people don't trust the models, they're not going to use them. If the war fighters don't trust, or the leadership, I've been doing a lot of work lately on platform readiness of military aircraft, and there's a lot of issues with trust that come down to data quality, the data quality aspect of it, where two different people working down the hall from one another may each have a copy of the same data and done different cleaning on it. So if we don't put that data, or provide access to that data in a way that is trusted, then the outputs, people are going to be comparing different things, and leadership's not going to trust the advice that they're getting, and then decisions aren't going to be made optimally. So there's all of those are facets, and we could kind of dig deep into any of them.
Yeah, I think that the one of the key challenges is all around data, and every large organization has challenges around data, as I mentioned earlier. Dr. Espinal, Arlene, what are some of the DoD's biggest data challenges in your experience?
Sure. I think Cheryl did, and both Ian and Cheryl did really good points there in terms of calling out some of the baseline. But I think overall the biggest challenges to the DoD is its own technological obsolescence, right? The inability to converge and optimize at the speed of what we normally see at the commercial market. That impedes the DoD's ability to grow and dynamically scale in a meaningful, mission critical type of way. Right, so you heard, Cheryl cover some of the trust components there. That entails the traceability, the equitability, the explainability, the applicability of data. But you can't achieve that state without first addressing some of the more antiquated impediments that have been a part of the DoD environment by no fault of its own, more so on just its own organic growth. Historically. So I think that, coupled with, the vast amount of data and their inability to tag, triangulate, or manage comprehensively to be able to extract that deep insight that's mission related, that continues to impact the DoD's ability to overcome some of those immediate data related challenges. And that's just on the data and technology side, right? I think there's also a significant component on at the more micro level around training and development of some of those players that are active duty, that are in this environment day in and day out, and that paradigm shift that hasn't quite happened as quickly as we would hope for it to have happened. That's critical to be able to transform individual capabilities as well as the technology and grow that collectively together periodically.
If I can just extend on that, I think that's a great point that Dr. Espinal makes about it's not just about the technology. It is about the technology, but it's not just about the technology. It's also about the training and how we use the technology. I'm reminded of when I was in Iraq, the Director of Operations asked me, when we had the withdrawal of combat forces in around, I think, 2009-10, were the terrorist insurgents targeting us more? So what I did is I was the chief of counter ID operations in Iraq at the time. So what I did is I just took Route Tampa, was the major supply route, and I pulled any significant activity that was plus or minus 50 meters off that route. Those were my data points. And I did a backwards anomaly detection and generally found that no, but in Nineveh province, which is the northern province in Iraq, 3 months before the withdrawal of combat forces, there was a statistically significant increase in attacks. Well, when I briefed this to the Deputy Director of Operations, the question came up, well, what happens if there was a significant activity 51 meters away from the road? Well, it wouldn't be in my data. What happens if the road curved and the line didn't match up exactly right? Well, it wouldn't be in my data. And so then the direction was, you have to go back and identify every single data point. Well, there were over 8,000 significant activities in my data set. And when you're paying, our contracted, operations research systems analysts, we're making something like $350,000 a year for their service in Iraq, plus whatever the RAP rate is. So to spend a week with 3 highly paid analysts going through all the data was a very expensive endeavor. Well, we did it. What did we find at the end of the day? Generally, the terrorists weren't targeting us except 3 months before the withdrawal forces in Nineveh province. But that goes back to, it's not just counting the data, it's what type of model or analysis do you apply to the data, and that oftentimes smooths over the error. It gives you better insights than simply counting the data. It looks at subtle differences that you can't see with the naked eye. And training our soldiers and service members to be able to take full advantage of AI or of data science requires not just a solution out of Silicon Valley. It also requires effective training and usage of that as well.
So Cheryl, I think that if I bring us back to the difference between analytical and operational AI, talk to us about some best practices that you've seen to get, to close that gap between when we have a validated model based on good data that we find is making good decisions. We productionize that model in real time. How do we get the consumers the full benefit of that decision advantage in the best possible way? How do we get it from the lab into the hands of the operators?
Yeah. Well, I think you nailed it at the beginning, Michael, when you said you got to start with the end in mind. And I think, whether it's in DoD or in the commercial space, culture, as a couple people have alluded to, the culture of trusting and truly using AI is really one of the hard parts. And when you start with the end in mind and really define your use case well, I always start with, how are you doing this now? If maybe the answer is we're not doing it now, but how are you doing it now? How well are you doing it? How much better does it need to be? Start from there. So, you can use various methods like design thinking or other, but don't let the technology drive the solution. Let the need drive the technology, because we can always build a model of some sort, but if we don't have the end goal in mind, we're not going to get a good model. What are the metrics? And I think sometimes this is harder in the DoD world because, and I've spent most of my career in the government space, but have also forayed into telecom and other financial markets, other industries. They've got a much more straightforward metric. Everybody can pretty much agree in a big telco that profit, customer retention, very straightforward metrics that are easier to define and to drive the design of your AI solution towards. In DoD, we have different, we have readiness, of course, we have cost minimization, but what's the cost of a human life? What's the cost of an insider threat that leaks, classified information? Those are really hard things to get your head around. So I think that's one of the challenges that I was, been thinking about in terms of how does DoD differ from the commercial world. But yeah, I think it's, sorry, go ahead.
No, I'm in full agreement, and I would take it another step, and I think the goal of AI can be to automate processes that were otherwise manually performed by a system or a human being. But to your point, right, automating a bad process doesn't get you any gain, right? So making sure that the business process that is being executed on, and the logic, that procedural logic that's being used along that workflow is sound, right? So a lot of times the AI projects will expose weaknesses in process and business process and in workflow that can be corrected, and that's really, in my experience, how organizations can really start transforming themselves. And I know certain leadership at DoD and within the JAIC, for example, are exposing some of those areas that could be improved from a business process perspective. And I think it's very much related to the mission of AI.
Likewise with data and data processes, I think, when you do a good job and try to build out, to that end solution, that's where we really find that there are data quality issues, there are data access issues. I think there's been a lot of progress in the last couple of years with people realizing how key data governance is. It's not the fun part of data science, but if that's not done right, then your models aren't going to be good, no matter if you got the best data scientist in the world on it.
Well, it's interesting that you mentioned the best data scientist in the world, because we know one of the challenges for all of us in this space is the lack of data science talent to actually build some of these, advanced AI systems. Ian, what are your thoughts on that? As far as the supply and demand of data science talent, not just for folks who are building models, but there are many stakeholders. You have data engineers, you have enterprise architects, you have data scientists, you have citizen data scientists. All of these people, all of these roles are really important to standing up a productionized AI system. Where do we stand in the market as far as the supply versus demand?
Well, I think that's a great question that faces the Department of Defense. The biggest issue is there are many new programs popping up at all different universities, right? So you have some programs will be stood up in an engineering school, some in a business school, some in a social science program, all with the title data science as a degree title. You have a number of certificate programs that are done. You have a number of online training programs like Coursera courses and such. And then you even have major cloud platforms offering like 40-hour courses. And there's a huge difference between, I came to Accenture from Johns Hopkins University. There's a huge difference between a master's degree in artificial intelligence at Johns Hopkins University and a 40-hour course that one of the cloud platforms puts on, right, in terms of hours of training. Yet it's not clear when we're actually looking at the recs. And you run, the challenge in practice is, if I get one of those highly skilled, like what I would call a full data scientist, right, coming out of a master's degree program, and I put them on BI work or some kind of simple basic data driven project, they're going to get bored and you're going to lose them to attrition. If I get somebody that has like a 40 hours of training and I put them in a program where I'm having them try and do computer vision or something like this, they're not going to be able to keep pace. And so I think the biggest challenge that the Department of Defense has is when they're defining their requirements and when they're writing requirements in contracts, can they be more specific about what the requirement is in terms of degree, years experience, what skill sets they want? I would add one other consideration. If I'm going to do natural language processing, take unstructured text and create a model that makes sense of that, I can do a lot of that work on my personal computer at home. But if I'm going to deploy a computer vision model, right? So like, some of the work we do at logistics warehousing, where you put LiDAR cameras that make 3D models of the warehouse and then identify the objects of where things are stored so you reduce inventory management costs. when I'm trying to deploy a model like that, I can't do that on my personal computer at home. I need additional resources. So depending upon the type of artificial intelligence you're doing, some are easier to be skilled up at home by motivated people. Others require resources that a university or a company would have. And so I think the government really needs to be careful about how they write requirements for contracts. I think they need to make sure that they vet that in the RFI stage, and that they don't allow bids to come in that are priced well below what is going to get them the skill level that they actually need.
Yeah.
And I think just to add to Ian's point, which are really great points, I think the DLD, historically has always operated as more of its own bubble, just by virtue of what it represents. But I think now more than ever, we've, as a whole, globally, right, and even across society, we've come to learn that everything is meshed. And so the DLD, I think, would also need to take a step back and come to the realization that when it comes to the talent pool, they are also competing, believe it or not, with the same commercial partners that they normally partner with. And so I think the question rhetorically for them should really be, how do we compete for the same talent, and what are we doing to set ourselves apart to be able to entice and attract and retain and reduce attrition, and do away with some of the legacy labels that through stereotypes and whatnot have been placed on the DLD as a whole, right? So we have to be considerate of the upcoming talent, what that generation represents. I think DLD also needs to take a more proactive approach to understand dynamically how they expect to open the doors and embrace this new generation. And to Ian's point, there are those that can do it on their own. There are those that prefer a more formalized path. Ultimately, at the end of the day, I think it comes down to, what are they doing? What is their strategic game plan to maintain, this top talent, and do it in a way where they're minimizing their attrition, not losing it to their competitors, for example, around the Accentures of the world, or the Facebooks of the world, or the Googles of the world, right? So I think that conversation that needs to happen as well, and needs to happen with more of a commercial lens. Although it's on the DLD side, they need to understand their competitors are no longer, strictly on the government side of the house. It's now more synergized across the board when it comes to talent retention and recruiting. And that workforce transformation, that plan, I think, is going to be critical for them to outline.
If I can offer just a quick anecdote to highlight your point, I retired out of the military out of CENTCOM down in Florida, and as they were trying to increase data scientists working in the J2, the Joint Intelligence Center, or even in some of the operational space, right? They were looking at pricing models similar to other places in Department of Defense, adjusting for geography, but they neglected that Disney hires a ton of data scientists. So as they lowered the rates, right, for data scientists, I think one case was Special Operations Command. They thought they were pricing something pretty well for a 1-year pilot for data scientists, but all the data scientists in the market could make about that same price working for Disney with greater job security. So they would choose that over coming there. So your idea about competition in the marketplace is key, and the Department of Defense may want to think about that in terms of where can they source talent, how do they need to price talent in order to get the resources, how do they avoid the risk of pricing themselves to a point where they can't get the talent and then they start sacrificing quality. And I think all of those are important considerations.
And I think further to that, it's also the trajectory that they're providing to this talent, right? Coming into the DLD sector, that career path is normally not as well thought out or chartered as you would see perhaps in a Disney, right? Or in a Facebook or Google. So what does that trajectory look like for this top talent that's coming in fresh into the DLD, or that they're trying to retain, so that it gives, again, the same talent pool the expectation in terms of where to have their sights on, and what that path needs to look like, and again ties back to the retention piece here and the minimization of attrition. So I totally agree, yeah, Ian. It's certainly a topic of contention if we can't tell, right? Just because we know it's very prevalent in our fields, and certainly something that's more and more, I think, by the end of this year and certainly going into next year, going to really, it's certainly going to predicate the longevity of a lot of business going forward.
I think one of the things that makes this really challenging, and also the thing that makes data science such an exciting field to be part of, is that there are really very different roles. Data scientist can mean so many things. It can mean a person with a statistics background, artificial intelligence. We like to think of it in terms of the roles as sort of data scientist, which would kind of be the person who builds models, data engineer, and a data engineer doesn't need the same kind of education as a data scientist or a data science researcher, but they need to know, I always describe it as the plumbing and wiring. They need to know where the data lives, how to connect to it, how to move it efficiently or access it efficiently, not necessarily move all the data over the pipe, but how do you go to where it lives and do your processing where the data lives, because that's really the trend in cloud environments. So again, a data engineer is really a different job, as is a data steward. Someone who really knows and cares about data governance, understands quality, understands level access, security and access at different levels. Do you secure? I think we were talking about this with Michael the other day. There's a lot of gatekeeping in data science. We can't get to the right data to do the job. So rather than saying, no, you can't have my data, we now have more sophisticated tools that allow us to say, you can have access to this data, but not this column. This is going to be masked or anonymized. So a data steward really has to understand all of that. And all these people need to be able to speak to each other, of course. We even have the concept in my company of data journalists. So people who are really in charge of the communication around data and data science. So how do you communicate to stakeholders, to leadership, to C-suites, what's really going on and what the impact of these AI projects is going to be? So I think that adds a lot of challenge when, as Ian alluded to, you just say data scientist. Well, what does that even mean? So,
well, just to pull the thread on that, your data journalists, we call data visualization experts, so that they're the storytellers and the communicators.
Right.
But the point I wanted to make is, the Army Track did a study a number of years ago. I think it was around 2015, 2014, so it's dated, but they basically defined those roles for what DoD needed, and I think industry has actually followed along in step. So I think that's an area where the Department of Defense actually was leading industry in defining the positions and the roles that needed to come together as a team to deliver that. But then I think industry, finding that they are successful on a financial bottom line, has been much quicker to adopt those roles. And I think the other key thing that I wanted to just tie a couple threads together is when you don't properly, you had mentioned that the data scientist required the deeper education. And so if you have a data engineer that's not qualified, well, they can't use the tools. It's very obvious. But if you have a data scientist that's not qualified, you just don't get the creativity or the diversity of models and analytic approach. So it's not as obvious to the C-suite that they have made that kind of compromise. And so when you miss out on a highly qualified data scientist on the team, that's where you're really sacrificing the product progress. That's where you have the greatest risk in the way you contract or the way you actually manage those roles.
Right. And further to that, Ian, that's where I think, would absolutely see the deterioration of the outcomes, right? The mission outcomes that are needed, which is where it's most evident. So I agree. That's certainly something that doesn't necessarily get looked at as prevalent at the C-suite level, but certainly something that is of critical impact otherwise.
Yeah, because you can have a data engineer count the data and do descriptive statistics, and you can have a data journalist or data visualization expert put together a great dashboard or a really attractive, interactive, engaging story. But it's the data scientist that's creating the model and moving you beyond descriptive statistics to actual true insight generation, that's putting the science into the process where you can actually test hypotheses, test decisions, and actually inform better outcomes for the mission.
And that just highlights, what I said early in the session around having a clearly defined use case at the beginning of these projects is so critically important. Otherwise, you'll find yourself in a perpetual science experiment that doesn't promote any type of mission outcome. It just maybe at best tells you what you already knew in a different way. So I think we're running up against our session time limit here. So before we go to the Q&A session, I'd like to ask each of you, what do you see the trend over the next 3 years in data science and AI? What is the key trend that you predict will occur? Cheryl, let's start with you.
I think it goes by different names, but what we call ML ops. So creating more of an end-to-end best practices process. So, we know every data science and AI project is unique, but there is a pattern. We've been at this long enough, that there are best practices. Michael, I know you're very familiar with the CRISP DM methodology, which was developed, I think, over 20 years ago. I feel like it's really stood the test of time. In fact, there was a CRISP 2.0 effort 10 years ago that never really got off the ground. But it's that covered a lot of the process, but there's even more. So to go from this idea of what is my problem, what am I trying to do, all the way to deployment, out on the edge, and putting process around that to make it less expensive, more tractable. I think that's where we really need to be. And I think there's been progress on that in the last few years, but I think that'll continue.
That's great insight. Arlene, same question for you.
Sure. So, I think to Cheryl's theme there around the ops piece of it, I think AI ops is also another one that we need to start paying attention to, where we start converging it, or again, seeing that paradigm shift, taking an AI ops type of environment and putting it more into more of a no ops type of environment, autonomously managing intelligent systems, growing and scaling on demand. Again, very intelligently, right? As would a human with minimum interaction or impact. I also think there's going to be a lot of ongoing work around AI modeling. I think digital twin is a big one. I also think biometrics is another big one, specific to the DoD, right? And how we start stacking these technologies against one another to really start leveraging total solutions. And ultimately, at the end of the day, AI is going to be front and center to be able to bring that to life. And if I'm looking further on, years out, we're still absolutely very much so in a rudimentary space when it comes to anything quantum. But I think at some point, quantum AI within the next decade or so is going to be an area where we're going to have to quickly figure out what our posture is going to be there if we want to secure any sort of competitive advantage around some nation competitors, right, when it comes to the defense space. So all areas that are certainly on my radar. I am sure they're also on my peers' radars here, and certainly something that's going to be of impact and meaning for the DoD's posture going forward.
Great. Ian, what are your thoughts?
I have two trends that I hope we will see, and one, it would be the division of labor. So I think as we start looking at really human and machine, and how humans and machines and AI work together, it's going to go beyond just the data scientist, data engineer, data visualization, or journalist. I think there's new roles in, how do we optimize where we have a human in a process versus automation? How do we achieve efficiency in the way we do compute, store resources? How do we look at security of models? If we use a public model to accelerate AI development, our adversaries have access to that base model, and it's easier to exploit. So as we start thinking about these things, it really develops new roles. And as we get rationalization around that roles, we can get better skills. We can decide what skill levels can we use with lower skill resources, like that 40-hour training program. Where do we need to have somebody with a master's degree? And how do we use them in an efficient way? So that is all the human and machine growth that we're seeing. And then the other thing that's related to that is, let's just call it human baselining. With all the discussion, we kind of didn't really touch on it in this panel where we're talking about like trustworthiness in AI, responsible AI. What's the human baseline? In my experience, most of the bias that you see in algorithms are transferred from human bias, right? Algorithms, according to Kathy O'Neill, are nothing more than opinions embedded in code. And so if you have people that don't agree on the labels, right, don't agree on how they code and classify the data, then that disagreement gets transferred into the AI system and you get an artificial ceiling on performance. So I think there is a trend where we're going to see that is just going to become increasingly important as we move forward.
Great. Well, this has been really informative. I appreciate everyone's time. I hope that the audience has enjoyed and found the session as informational as I did. Look forward to your questions. And with that, I'll turn it over to Brad.
Thank you for that interesting panel. Next, Cameron Izzy will be taking the reins and talking about the keys to successfully deploying AI applications, applying AI ML applications to helicopter predictive maintenance in our first Tech Talk. Cameron Izzy is the lead machine learning engineer for Novetta out of the Tampa Solutions team. His educational background is in high energy physics, and he started his career working in electro-optic sensors and image processing. His current focus is on integrating machine learning capabilities into production level software solutions to meet various DoD applications. Please welcome Cameron Izzy.
All right, thank you, Brad. Happy to be here. So I'm Cameron Izzy, I'm from Novetta, and I'm going to be talking about the keys to successfully deploying AI in terms of applying it to our case, which was helicopter predictive maintenance. So a little introduction or background on myself. I'm going to cover this real quick. I actually have my background's in high energy physics, did 4 years of research over at CERN for the CMS detector. That led me to a career at Lockheed Martin doing electro-optics, which led me down the role of deep learning, where I really got into it. Got a couple of IP awards for some algorithms I developed, and then came over to Novetta for 3 years now, leading a team of ML engineers and data scientists here in Tampa, architecting solutions, integrating with the customer, and just working with the Jake a lot on deploying AI applications in the DoD. So the theme of this talk is going to be AI is more than a model. Basically, the agenda, we're going to go over what does it really mean to apply AI, understanding the people, the problem, and how to get to where your AI is going to be, then building that trust with the customer for AI, and then from there, how do you actually build something useful for that customer? And then we'll just wrap it up with a quick review. So what does it mean to apply AI? First, to start doing that, we need to understand that AI, like we said, is more than a model. Applying AI is from data curation to software development. A lot of people think it's data science. Data scientists just make a model and, boom, AI is deployed and it's useful for the customer. It's a lot more than that. And then the data science process, I think it's becoming more common knowledge that it's not just that training the model process. That little linear flow on the diagram down below is kind of what everybody's starting to learn and realize, that there's a lot of data preparation. Then there's the modeling, then there's a lot of tests. You might have to go back to your data preparation as your test, and then you get to the deployment. And the big thing is, we now know that subject matter experts play a big role in this, but they're traditionally just included at the data preparation stage and the deployment stage. And the question is there a better way to apply AI than this traditional data science flow? And in order to start answering that question, we need to start with understanding our customers, their process, and their problem. So down here, a team in Tampa likes to think of Westheimer's discovery, which a couple of months in a laboratory can save frequent hours of being in a library. We like to apply that as more than a couple of minutes with a good conversation with a customer can save you hours of data engineering and scratching your head about what's going on in the data. So you really need to understand that user's problem and that user's environment. So we like to work with the customer a lot in understanding exactly what they need from their AI and ML, mainly because a lot of times these people aren't very familiar with AI and ML. And like when we get to the use case of the helicopter maintenance, you'll see that. So what they think they need early on isn't actually what they need. And then you also need to learn their environment, because in order to deploy the AI ML, you can't disrupt the user's workflow. It's supposed to augment the user's workflow, and you can't drastically change their system. Definitely when you're an outside customer coming in order to fit this tool into their system, you can't expect them to have a major engineering lift just to integrate a simple model into their workflow. So giving you some background on the rimfire process, which is this historical maintenance data to apply to engine teardown models. And this was our customer. Basically, we were given 15 years of historical teardown assessment data. And if you look at the diagram up top, basically what that is when they have a problem with the aircraft on relating to the engine or something, and they pull an engine, they make a determination whether it needs to be shipped back to depot or not. But basically, once they pull that engine, they start collecting a little bit of data. And if it gets shipped back to depot, there's this whole process of collecting data at every point that it's in depot getting repaired. And it's stored in something called a TDA generation report. So they generate these reports that are just teardown assessment reports that get sent off to an ERB 3 times a year for about 3 days. An ERB, an engineering review board. I used to sit in them at my old job. They're a very long, strenuous process. A bunch of engineers are in a room. You're looking at data and you're trying to determine why that engine or what broke and what caused that failure. So the ERB does this 3 to 5 for 3 days, 3 to 5 to 4 days a year, depending on how many engines broke that year. And basically what they do at the end of it, they come down to about 5 manual labels. So that is a lot of time and effort just to label something. And what we found in our data was 40% of the returns weren't returned for any failure at all. So the ERB's goal in these is to find like real new problems and interesting engineering problems that they can go back to the manufacturers and like, hey, you have a flaw in your design or it's not working. They're not interested in focus on like, oh, the sensor messed up, so we pulled the engine accidentally. Like, yes, that's useful data down the road, but it's not the job of the really smart mechanical engineers and other folks that are there. So they're wasting a lot of time with these failed labels. So that was the key to identifying where ML might be able to be helpful for them. So we talked to the customer. At first, they wanted a tool to predict when the engine was going to fail on the helicopter, but they gave us historical TDA reports to do that. So we're talking about a model that would have to work on wing with data that was collected after the fact that the engine was already pulled. So that problem would have probably required more like sensor data where we had something else. So when we were talking to the customer, we were able to identify this problem with them pretty early on and sit down with them and be like, hey, we think there's a better avenue that we can go with this data. It might help you guys. And the engineers we were talking to were the ERB guys. And when they walked through this process, they're like, yeah, we're spending so much time in the ERBs on these no evidence of failure things. It'd be great if there was a way to just, automatically predict that. So we were able to build a model that basically predicted those 5 labels for them to a pretty good degree of accuracy to help triage the ERB for them efficiently, which was a win for our customer because now we're saving a lot of time for them. So there was that identifying the problem in the environment, which then came to building trust. Trust was the big thing because, again, these are all mechanical engineers, maintenance engineers, SMEs, not in the software world at all. So AI and ML was new to them. And a lot of times, many people may know that new to AI and ML, they don't see the value in it right at first. You hear a lot of things. It's very complicated. It's hard to implement, overbearing, all this time to keep it up, retraining, all this stuff. And if you don't have the expertise on your team, you're going to be outsourcing those expertise and it can get very expensive. So program management tries to shy away with it. We saw all that with our customer. So the way we eliminated that skepticism with them, though, is finding that true pain point like the ERB, which it's not the super cool on-wing aircraft solution that everybody wants to be the ones to say that we're doing that, but it was an actual pain point for these folks down at the ERB, and it's helping a lot. And then going back to that original model, instead of just including them at the data preparation stage and deployment stage, we include our customers and subject matter experts in every step of the process. We get a lot out of it and they get a lot out of it. they can now start trusting the model because they're involved in conversations during that training process. So they kind of start seeing how the model's thinking, why it's making decisions it's making, without, at the end of the project just getting it like, hey, trust this model. So they're there every step of the way. It really helps build trust. And then they start seeing the value of it because they're actually putting their input into like what they want that model to do, which is a lot of value. So if you're a customer and you're sitting there and you're kind of skeptic about this at first, but you're there every day and you're there during the testing phase and you're giving feedback, you're starting to see the problems with it and you're helping fix those problems. So you can trust that it was fixed correctly rather than being distanced from it. So that brings us back to really leveraging the customer. We do this all the time. We always like to say our data scientists are excellent at manipulating data and building models, but they lack that low level knowledge of the data. They're not helicopter engineers, they're not mechanics, so they don't have that level of knowledge that's really abstracted if you're not including the SMEs in every step. So the SMEs are the key to getting that, and they can identify things that sometimes a data scientist, and it happened a lot in this problem, that may look like an error in the data. Like maybe for a couple of years, something like a label changed drastically, and you're like, oh, maybe there was just user input, or maybe for a week it was user input. Being able to go back to the SME and ask that question, they can identify, oh, now that's when we had this one, event that happened or something like that. That's super valuable information that just a data scientist is never going to be able to capture. And they again really help understand how that data is being used, which helps us, like in our case, build new features to make our models better. And it allowed us to clean our data more accurately to how the SMEs are using the data. And then while you're in that, you're really getting to understand their environment and the architecture of which they operate. So when you're getting close to that deployment stage, you have a better idea of how to build your app to actually fit in their environment that will integrate super smoothly, rather than when you get to the end of the deployment stage of just building a black box and handing it over, which again can cause a lot of conflict if the customer doesn't want to have heavy engineering lift on their side. And one of the biggest things we learned is determining when to stop your ML integration. Every data scientist might tell you they always want that 100% accurate model, but when it turns out to the SME, sometimes 80% is good enough. Sometimes 70% is good enough. Sometimes they just need something to help them just a little bit to augment their workflow and make their life 1,000 times easier. So they're the guys that can really input that during that training process when they're reviewing the results of the model, going, hey, this is actually pretty good. Yeah, it's missing some of those really niche cases, but it's getting all the stuff that I actually don't really want to spend my time looking at. So that's massive input. So once you have all that, then it's building something useful for the customer. That's the key, right? Everybody wants something useful. So again, AI is only useful if it's accessible. The best model in the world can predict 100% with 100% recall. It's no value to anybody if it can't be used. So these AI tools need to be easily integrated and accessible to the user. So our customer had an established environment. They already had a web application where they're doing these ERB reviews, doing the database stuff and everything. So we didn't want to disrupt that workflow. So you've looked at the diagrams, it's kind of what they had. Engines, when they got to depot, they started getting tear down. They're collecting that data that goes into the database. And that last little block there, you can think of as their web app that they're using to review. And that all lived in a GovCloud system, so AWS. That was super good knowledge that we got right off the bat by interacting with the customer. So we knew how to build our app using those kind of technologies. And then we knew from talking to them that it needed to scale because depending on what's going on in the DOA time, engines can scale up or down, which means problems scale up or down. So we're kind of in a downtime right now, but we know that might not be the case in like a year or two. So our solution and our ML flow to that was basically augment their flow and live on the outside of it. We're not going to disrupt their standard workflow, but we're going to have our model interact with their workflow from an outside point of view. So we did this by using API features. Again, they already had a web app, so all we had to do was build some endpoints for them so that they could send the data they needed to the model and back, and get without actually messing with their database, destructing their web app in any way. And then the biggest thing was it needed to be scalable and they need that ML ops training because they did not want that lift of having to hire data scientists or constantly contract out when this model, as data changes, as we all know it does, through time. So we were able to, talking to them, be able to put an ML ops flow for a retraining cycle as we saw, things training and have indicators by working with the SMEs on what a good indicator would be when to kick off a training cycle. So again, great AI ML just integrates super easily. And that's how we were able to build this tool within 9 months with the customer and integrate it into their production or workflow within 9 months. So some of the technologies we use to do that, again, a completely API interface using Docker and AWS GovCloud, which is the same technologies that they were using, S3, which is similar to what they were doing, just working with their developers and their SMEs on how to do this to integrate super simply and quickly into their system, and also keeping that scaling in mind so that in a year, if there is a ramp up, our app doesn't go down, doesn't break. It's not going to disrupt their system. It's going to allow them to work fluently through their workflow. So just a little review here, coming up on time. So again, the keys to the AI and ML success for us, again, is engaging that user through every step of the way. Don't think once you get that data, it's time to, just hand it off to the data scientist and like, okay, we'll talk to you guys again in 3 months. Have your data scientists talking to the subject matter experts, have them, find that key person to talk to that will give them that insight into data that will just help them make their lives a lot easier when they're doing their feature engineering and their model training. Ensure that AI can be deployed in their environment easily. Don't hand a black box off to the customer that is going to require them, 6 months of FTE time to integrate into their system, because that's going to deter them from wanting to use it. If you work with them every step of the way, your software developers, your ML engineers can identify those easy wins that will make a deployment so much faster and easier for the customer. And then, integrate the users and SMEs throughout the development. Again, can't stress that enough. You get all your proper model training, you get your rapid implementation, when to stop training, when your model is good enough for that customer, and really build that AI. And the biggest thing then is your customer is going to have that trust in what you're handing over at the end. And it just makes them so much more willing to use the AI. And it also makes them more willing to find new places in their system to apply AI and, really expand out using AI and ML for, more than just what you were initially brought on to do. So that's the theme. AI is more than a model. Keep that in mind throughout everything. You will, really get a lot further than just getting a big data set, training a model, and hoping that it one day makes it into production.
Thank you, Cameron. We're now going to take questions from the audience. We have several of our speakers on today to answer them. So with that, let's get started.